Hello everyone, I am Dr. Sameena Naaz, Associate Professor, Department of Computer Science and Engineering, School of Engineering Sciences and Technology, Jamia Hamdard, New Delhi, India. And today I'm here to talk about one of the recent developments in the field of machine learning, which is federated learning. So before I actually start with what we have to discuss, let me present my agenda item here. So I'll be discussing about 5 important points here, and they are why we need federated learning, what is actually meant by federated learning, and how it is actually used in the healthcare domain. Finally, I'll also be talking about the impact of federated learning on the various stakeholders and the challenges in federated learning. So the first question is, why federated learning? If you look around yourself, you'll see that data is being generated in all the smart devices that you have with you. Maybe it is a computer that you are having, maybe it is a mobile phone that you have, the smart buildings that are there around you, or the smart automobiles which we have these days. Now we know that the data which is generated at these different sites, that can be used for the generation of the models, the machine learning models. Now, if we have on-device inference, that is, we are able to develop the models from the data which is being generated on these local sites, then we will be having some of the important features, which includes improved latency. It can work even if you are offline. It gives a better battery life, and it also has the privacy advantages. We can generate models independently on these devices, but do these devices have enough data to yield a good model? Because we know that when we are talking about machine learning models, more the amount of data that you are having, better is the accuracy of the model which you will be able to get. Now, federated learning helps us to achieve that above mentioned advantage without compromising on the model's accuracy. That is, so some of the important features that we have, some of the important things that we are getting from these federated efforts is one important thing, or I should say the core of this federated effort is that you'll be able to get robust models with large scale training. How we are able to actually achieve this? Because we are having collaborative learning without centralizing the data. That is, the data resides on the local devices, but we share the model updates. That is, the model is being generated on these different devices, and the parameters of these models, they are being sent somewhere where the aggregation is being carried out. This particular technology addresses the privacy and data governance challenges also. The AI training occurs locally at each participant, and then, as I said, the model updates are shared. Participant can control the data access, and they have the ability to revoke it. Suppose I'm one of the participants, I'm giving my data, not actually giving, but my data is available for the machine learning models training. But because effectively I have not shared this particular data with anyone, so whenever I want, I can actually revoke that particular permission. So it is in control of the person who is actually using or who is actually providing the data. Now, the next question is, the second agenda item was, what is federated learning? Now, we all know that when we talk about the traditional machine learning, we know that it relies on server-side data sets. And the data set is split into the training and the test part. The model is trained on the server, and finally, that particular model is deployed. This is the architectural diagram. We have got n number of devices here. Device 1, 2, 3, and so on. All these n number of devices, they are sending their data to a central repository. This central repository will actually split the data into the training data set and the test data set. The machine learning algorithms will be applied on it. The model will be developed. And finally, once the model has been developed, whenever any new data comes in, we know that the model will be used for the prediction of the output from that particular data set. Coming to the second thing, that is how this federated learning works. We have got a federated server in case of federated learning. There is a global model that we are having. Suppose I say that the version of this global model is V0. These are the edge devices that we are having here. Each of these edge devices has their own database. Your mobile is having its own storage. Your PC will be having its own storage. Your laptop and similarly the smartwatch that you are wearing, all these will be having their own storage. A global model is first developed. Now, this model may be an untrained model as well. And once it has been developed, it will actually be sent to all the edge devices that you are having. So you can see that here we have got version V0, 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 and V0, which gets deployed on all the edge devices which we are having. Once this has been done, all the devices out here, they will be generating their own data as well. So then in the next step, these devices will try to refine the models by using the new data that has been generated on them. So I have represented these different new models by different colors. I have color coded these different models. So the model here is color coded in this manner. The model which was generated here is this. For this device, it is this model. And for this device, this is the model that has been generated. After that, all these models are sent to the federated server. And this federated server will aggregate these models to generate the next stage model. This model which gets generated now at the federated server will then be sent to the devices, to the edge devices again, and the same process will be repeated. And after a certain number of iterations, we'll be able to get a in fact, I should not say this also. This process keeps going on, and we are able to get better and better model in this manner. So this is the basic concept of federated learning that we are having. Now, the third thing is that how we can use federated learning in healthcare. So before I come to this, that is how I can use the federated learning in healthcare. Let us see that how AI is being used in the healthcare or in the medicine domain. Whatever type of application you are talking about, maybe you have some pathology data, you have a radiology data, you have electronic health records, you have ophthalmology data or genetic or any other type of data that you are having. We do have applications of machine learning for all these different types of data items. If I take an example, or let me talk about the models that we have in the machine learning arena, and all these models are actually being used. So I talk about the convolutional neural network. This is being used in various application areas, especially in the case of images. We are using recurrent neural network. We have generative adversarial network, reinforcement learning, deep neural network, distributed models, and the latest one that has been added, about which I'm talking about here, is the federated learning model. So we can say that we have moved from the simple machine or the deep learning technique to the distributed machine learning or the distributed deep learning technology. And finally, now we are in the federated learning domain. And this is my topic of discussion today. Artificial intelligence, and in particular deep learning, has become an important technique for computer-aided medical applications. One of the common core requirements for learning a robust and accurate algorithm is the availability of an extensive and diverse data set. Now, there is always a possibility that you have data from various places. But we know that the healthcare data that we are having, it is very sensitive and personal. And the hospitals, they do not, hospitals or the healthcare providers or the pharmaceutical companies, they do not want to share their data. So, because there are many policies also which restrict the sharing of these data items. So what happens is that it is a major challenge for medical applications, because patient data needs to be protected and cannot be easily shared. And this federated learning that we are having, it addresses this problem by enabling to learn collaboratively across several institutions without explicitly sharing the patient data. How that is done? It can be done by using the concept of federated learning that I've discussed in the previous slides. I'll take some real-world examples of the collaborative work which is going on in the world. One of the examples is the detection of air pressure that is needed for the COVID patients. How much oxygen supply is needed for any particular COVID patient. So one of the papers or few of the papers which have talked about this are listed here. They are all these papers are from year 2020, when COVID was at its peak. And what the authors in these papers have done is that they have taken the chest X-ray from various patients, and they have used these chest X-rays on a pre-trained ResNet34 model. That is, the transfer learning concept is being used here, and we achieve or we obtain some features from this at this end. Along with the chest X-ray, they have also used some EHR features, which are some of the vital signs of the patients, the demographic data, as well as the laboratory data. These are some other sets of features, and this output from the pre-trained ResNet34 model and the features which are present here, they are then fed to the deep and cross network, finally to obtain the target, which is actually the oxygen level which is required by these patients. Oxygen level 0 means that the patient will be very easily able to survive in the room air. That is, there is no need for providing any external oxygen supply. Low flow is actually 0.25. High flow has been marked by 0.5. Ventilator support was 0.75. And if this value is 1, this means that the patient died. Now, in this particular slide, what I'm trying to show is the machine learning approach which was used by these four in these 4 different papers. After this, the same concept was used, but we used the federated learning approach. NVIDIA Clara used the federated learning approach, where 8 different countries were involved and 20 different locations were there. So these 8 different countries collaborated for the data, and they did not share the data with anyone, but it was the federated learning approach which was used to develop the model. And this particular research has been shared in the paper which was published in 2021. Few more examples include, 2 of them are from European countries. One is the French funded health chain grant, where 4 different hospitals were there. These are the academic hospitals or the academic medical centers that contributed for the breast cancer and melanoma prediction. They were using, or they used the Ovkin Fed AI infrastructure. Second project, which was a grant by EU, which is known as the Melody Grant, it had the pharmaceutical companies, 10 pharma companies came together. They again used the Ovkin Fed AI infrastructure, and this was a collaborative project for the drug discovery. Then one more that we have here is the collaboration between Ovkin, King's College London, and NVIDIA, which was used for the therapeutic area focus, as well as multi-model and multi-class segmentation. And it was actually there for the brain tumor identification. So work is going on. These collaborative works are going on all over the world, and federated learning is giving very good results in all of them. Now, the next thing is, what is the impact of federated learning on the various stakeholders that we have? So we know that there are various stakeholders. We do have clinicians, that is the medical practitioners that we are having. We have the patients. We have the various researchers who are working in this particular domain, the hospitals, as well as the manufacturers, and all of them, they are being benefited by this federated learning approach in one way or the other. Last thing is that what are the challenges in federated learning? So talking about this, some of the challenges that we do have here is the workflows. That is, where previously I said that there is one federated server, and when the model is generated at the individual edge devices, this model is sent to the federated server, and the federated server aggregates it. Now, this is not the only one method which is used here. We can have other methods as well, where the peer-to-peer approach can be used. That is, these edge devices, they are generating their own model, and they are sharing their model amongst themselves to get the aggregate of these. The second thing that we have is the data leakage and security. Now, although we say that the data is safe, that is true, that the data is safe because it is not being shared. But there are some mechanisms with the help of which the model updates, which are moving from one place to another or from one site to another site, they can also be traced by the intruders, and they can be used for getting some information about the data. So research is also going on in this domain. That is, if we can have privacy preserving mechanisms for the federated learning. The next thing is the orchestration. That is, what is the manner in which when these models are being sent maybe to the central server, then how they are actually taken or downloaded, or I should say they are used for the generation of the aggregate. This is another important point, or the challenge. The second one is the device agnosticism. That is, suppose I talk about MRI. Now, the MRI can be taken for the same disease. The MRI could be taken at different health centers, and they could be using machines which have been manufactured by different manufacturers. Obviously, there will be some difference between the outputs that are obtained from these manufacturers' devices. So it is very, very much important that the federated learning approach that we have is device agnostic. That is, it does not matter that which particular device has been used for taking the data. All of them should be, we should be able to use all these data for doing the processing. The next one is data normalization. We know that when we get any data, we normalize it. We are having that data with us, we are able to see the data, and then we normalize it. But when we talk about the federated learning approach, we are not seeing the data because the data has actually not been shared by us. So it is very, very much important that the data normalization is carried out in a proper manner. We know that while sharing these patients' data or any other data in the medical domain, the data regulations are very important. We have the HIPAA, which tells us that how much data or in which manner we can share the data. So we have to be very sure that we are not going against any of the regulations that are there. On top of all this, I would just like to conclude that trust is the most important feature, or the most important thing that we need to have when we are talking about AI in medicine. And this trust is there as an inherent feature of federated learning, because we are not sharing the data that we are having. So I would like to conclude my talk by just saying that federated learning is a very good technology which can be used for in the medical domain for getting better and better methods which can be used for patient, for the advantage of patient as well as for the advantage of all the other stakeholders that we are having. Thank you very much.